Going to work on solving quadratic equations by graphing. And in order to do that, you will want to be able to graph using pen and paper. That's an option. And another option would be to use a graphing tool, either your graphing calculator if you have one, or you can use Desmos, the free online tool that we've been using. All right, so let's see how we're going to approach solving quadratic equations by graphing and what that means to us. Let's start. So whenever you start writing quadratic functions, you want to create what's called a related function. What that means is basically you replace the y with a 0. So for instance, right here, it's the same to say that y equal to ax squared plus bx plus c, or standard form, right, is the same as replacing the y with a 0. They actually mean the same thing. At the same time, if I were to simply switch around the positions without changing the signs, these are the same functions, all right? So there are actually 3 steps that we take by solving by graphing. All right, step 1 is to make sure you create the related function, meaning the function should be written down in standard form, okay, from highest degree to lowest. And then we graph the given function, whichever tool you're using, and then you find what you call the zeros of the related function. So let's make a quick review. What does it mean to say that you're looking for the zeros of a function, right? So that's a concept you will have to remember. When you talk about zeros, you're actually referring to your x-intercepts. So ask yourself, okay, well, where does this graph cross the x-axis? At which point, or does it even? Because now we need to recall something that we did a while ago. Remember when we said that quadratic functions, all right, may either have 2, 1, or no zeros at all. 2 zeros is when you try and graph the function and somehow it crosses at 2 points on the x-axis, like so. Or maybe it's exactly the vertex that the function crosses on the x-axis. Or at times, maybe it doesn't even cross the x-axis at all, like so. All right, so there are 3 possible scenarios when you talk about zeros of a quadratic function. Let's explore more a little bit on these. All right, let's go forward. All right, so right here I have a couple of examples that we will work on. So the first one right here is 2x squared minus 2 equal to 0. So step 1 was to make sure you write the related function so that you can graph it on your graphing tool or graphing calculator. So to say that a related function could be the same as 2x squared minus 2 is actually equal to y, or f of x, those are your related functions. And so when you go ahead and graph them, you're supposed to produce this function right here, or this graph right here. What happens is, to solve for the quadratic function by graphing, you're actually looking for the zeros, or the x-intercepts. Where does the function, or the graph, cross the x-axis? And right here, you're seeing that, oh, hey, you know what? There's actually 2 points that it crosses on the x-axis. And they are, respectively, the red one right here, -1, 0. And the other one, right here, the purple one, is 1, 0. And these now are your answers. So we say these are the 2 zeros because the graph crosses the x-axis at 2 points. Or, all right, class, be very careful about this. In some books, instead of writing the coordinates of the points, okay, some books will just say, okay, the 2 zeros are when they are at -1 and +1. Okay, notice how I'm not putting a parentheses on this one, because if you do, it would represent a coordinate point, and you don't want that, because you're just trying to say that the zeros are on these locations on x, on the -1 and on the +1. Okay, so you either write in the first method that I showed you or in the second one. All right, let's now look at part B. In part B, you have a function -x squared minus 4x minus 4 equal to 0, which is the same as saying that I have a -x squared minus 4x minus 4 equal to y. Okay, related functions. And also, you know that the leading coefficient is a -1, thus the graph opens downward. What's really cool about this is now you're seeing a second kind of zero. We had 2 in the beginning. Now with this example, there's exactly 1 up here, and it's actually the vertex. So it so happens that whenever the graph crosses only at one point, it's actually the vertex. That's the only option. There's no other choice here. It only crosses at one point because it's the vertex. And so you can see right here that the vertex is at -2, 0. So again, you say your answer would look something like this. Well, the zero can be found on -2, 0. That's a possible answer you can give, or you can just say -2. Okay, both are acceptable answers. So make sure you pick one way to write your answer down. Of course, in addition, I do want to show you the steps in using your calculator, whether it's on your phone or it's an actual physical graphing calculator. Okay, and later on towards our next example, I'll show you how to use Desmos as well. Okay, so you can also confirm the solution by using a table. Okay, either you manually do this if you prefer to manually graph it. Okay, but on a calculator, here's how you can find it. So if you remember, we could go to the following functions in your calculator. You press on the second button. That should be found on the upper left corner. You'll see it right away. And then now you're going to look for this second button, right where it says graph. That's now going to be the upper right button. Okay, somewhere right there, yep. And so you press the first one and then the second one. And when you do, this table shows up right here. What's really nice about this table is you can scroll up and down, and it changes your x values depending on what you need, and of course your y values change as well. But notice that if we're looking for what you call the zeros of the function, what you're looking for is the x-intercept, right? When you talk about the x-intercept should have a y value that's 0, and that's exactly what this table is showing us right here. You see it? The x value at -2 has a y value at 0. That's why we're saying that that is in fact the 0 of the function. Okay, all right, so sometimes it's exact like so, you'll see it right away, but other times if you look at a table, the zeros might not be exact, so you'll have to change a little bit here. You need to change a few settings, right? All right, so you now know how to spot the zeros when you see a graph. Now let's look at the next example. All right, so let's actually set up the example right here. Okay, first, step 1 is to make sure you have the related function. Now check, is this in standard form? No, it isn't, so you'll have to rearrange it. So now let's actually change it to standard form. In this case, you do want to move the 4x to the other side of the equation, like so. You'll come up with x squared minus 4x plus 5, which is now equal to 0. And so we say a related function for the given is when you have x squared minus 4x plus 5. And this is what you want to type into your graphing tool. And when you do, all right, let me show you what happens. When you do, oops, all right, let me get my arrow right there. And when you do, you will be able to come up with the following graph in your calculator. So notice how it looks very nice. It's opening up because it's a positive leading coefficient right here. And so we say, oh, hey, let's take a closer look, like right there, okay? Well, what do you guys think? How many zeros are there, if any? And if so, where is it? What is the location, right? Okay, so if you look closely, I can zoom it in for you right here. All right. If you look closely, you will see that it doesn't really touch the x-axis. See how there's a gap in between? All right, and there is an option in your calculator to be able to zoom in. Well, we don't see it crossing the axis, so therefore we say that this function right here actually does not have any zeros. So we can confirm that by looking at a table of values like so. So take a look. In the y column, right, you're supposed to see zeros, but you don't. So then we say for part C right here, the function actually has no real zeros. So okay, write it down. No real zeros. Okay, so you cannot say that there are no zeros, because in the near future you'll find out there are zeros. They're just not real. Okay, so that's the main difference. So what you want to say, be very specific, is that there are no real zeros. Okay, so this happens if your graph, your function, does not cross the x-axis. Okay, all right, so in the next screen, you'll have a chance to actually practice. So you will have a chance to pause the video and then give yourself some time to try the problems out and then play again whenever you're ready. Okay? All right, here we go. All right, so I have 3 examples you can try working on. So solve each equation by graphing the related function. So go ahead and pause the video right now so you can practice. All right, so part 1A, let's look at the given. So if you were to write the related function, because it's not in standard form, you want to move all the terms to the other side, to the right side, so that your standard form, or your related function as well, will look like x squared plus 8x plus 16, which in turn you will be graphing, all right? And when you do, okay, you'll find out that the 0, there is exactly 1 0, super cool, it's the vertex, found at -4, or if you were writing your answer this way, at -4, comma, 0. All right, awesome. And then in the second one, okay, notice how the negative x squared is on the right side, which means you want to move everything on the right side, okay, wherever the x or the leading term is. All right, let's move them on the other side. Here's your related function right here. And of course, you have y equal to negative x squared minus 6x minus 10. And so when you graphed it, it's a function opening downward. Okay, so let's see. All right, please confirm that there are no real zeros. The graph doesn't cross the x-axis. Or there are no real solutions or no real zeros. They mean the same thing. All right, awesome. And on the last one, okay, you don't need to rearrange it. It is in standard form. So instead you say, okay, here is the related function. All right. And when you graphed it, it's a graph opening downward. And as you figured out by now, the graph has moved upward, which means if it's a graph opening down and it is way higher than the point of origin, then it should cross the x-axis exactly at 2 points right here, at -2 and 2, or at the given coordinates. Okay, so hopefully you're checking this, the answers, comparing it with what you have, and rechecking, confirming, reconfirming. All right? All right, so I'll bring you forward to the next part. In the next section, we're actually going to work on application. Okay, so much like what you did in the last section, you worked on functions where you had to create equations to show the movement of an item dropping at a specific height or from a specific height. So this dolphin jumps out of the water with a given function that models the height above the water after a few seconds. The question is, how long is the dolphin out of the water? Okay, so think about this. You have your x and y axis. This is really important that you know what each of those axes represent. So x represents your time in seconds, and of course the y-axis represents your height in feet. All right, so I think it's in feet. Yep, there's no unit given, so we'll assume it's in feet or any other unit. All right, so this is the dolphin jumping out of the water. Keyword, cues, jumping out of the water. So you're coming up here. So this is the dolphin, the blue one right here. It's going up, and then of course it forms your parabola. At a specific point, it just goes up as high as it can, and then it drops back down into the water. The question goes, okay, well, how long does it take for that dolphin to be in the air and land back into the water? Okay, so then we're going to find out how long it took. All right, in order to do that, you do your graphing, whichever tool you're using. All right, I've done that for you down here. I typed in my equation like so. And then what I did was, okay, I generated a graph. That's what we've been looking at, okay? And I do want to confirm because I'm not sure. I don't really know what units these are, but I know they're changing by 1, okay? I know they're changing by 1, so let me be very specific. Let me try and look at the table of values. All right, so obviously your time cannot be negative, so we're going to eliminate these values. You don't need them because time needs to be positive. So we're starting at 0, going up. All right, so notice how the first 0, 0, we said it's an x-intercept, right? Okay, that's because that's the beginning point. It starts from the point of origin. We're now looking for this other point right here. But notice how between 4 and -24, that's where the 0 should be. But we can't see it. We can't really tell where it is. All right? So if you try and zoom in, or if you use Desmos, okay, I'll show you in a second. If you use Desmos, it is a better tool to actually give you an accurate reading, and you'll find out that it actually takes 1 point. Okay, let me write it down, I guess right here, right next to the question. How long is the dolphin out of the water? It actually takes 1.25 seconds. Okay, and that answers your question. So from the beginning all the way to the time it lands back into or on the surface of the water, it actually takes 1.25 seconds. Okay, so you see my computations down here. This is just to help you get a better view of how you're going to set up your graphing calculator if that's what you're using. It really helps to know where the vertex is. First, you know that the graph opens downward. Now you need to know how high the graph could go because you want to set up your calculator really well. And this is what I mean, okay? Your calculator will not look like this when you hit graph. You know this. It's in the middle. The x and y axis are in the middle. So you'll have to do some tweaking. You need to do some adjusting. So let me show you right here how we can do that. So to adjust the window on your calculator, if you're using a graphing calculator, you click on window, and there are options with the x minimum, x maximum. Okay, you're basically telling the calculator what would be the lowest x value you want to see in your graph, or the highest. And then x SCL means the scale of x. What is the interval you want to use for x? So you just want to change it by ones. The preset value on your calculator is 1, but you can change it. If you want it to go by 0.5 or by 2s, you have that ability. And it goes the same for the y values. Okay, so in this case, what I did was I simply referred to the x scale as 1s. Okay, I did not need to change that. And for the y values, I did not change anything either. So that's why it was important for me to list down the vertex. I know that I don't need to change the scales or the height or the length of my coordinate plane because I know that the y value goes up only as high as 6.25. So I don't need to go way higher. Okay, so this was just the general setting. The only thing I changed, all right, in my calculator was this. I changed the lowest value to 0 and the lowest value for y as 0 as well because I know that I'm only using the positive values because I can't have a negative height nor a negative time. Okay, and of course if you want to reset your window, you don't want to leave your setting that way. It might confuse you in the future, right? Here's what you can do. You simply want to go ahead and click on zoom. All right, it's in the middle, the top middle button, and then you select number 6. It says Z standard. What that does is it resets your window and set it up to the standard one, okay? The middle X and Y axis that you've seen from the beginning, okay? Well, so in the next page, you're actually going to be able to practice on an example. All right, let's go ahead. So at this point, you can stop and pause the video and give yourself some time to practice and find out how long the dolphin is out of the water. All right, so another dolphin jumps out of the water, this time represented by the given model, okay? And so we're asking how long is the dolphin out of the water. So go ahead and pause the video at this point, give yourself some time to try this out. All right, here we go. So what we're gonna do is we have the function, okay? We know the related function is when y can be replaced by 0. All right, so let's look at that. We typed it into our calculator. This is the function we have. Okay, and now we're looking at the graph. This is the graph I produced. All right, so again, you can change your settings. Okay, change your settings to whatever you need it to be. For this example specifically, the x minimum was 0. The x maximum, I believe, was 10. I left the scale as 1, so the intervals are by 1s. And then for the y values, I set it up so that the y minimum is 0. And then I believe the y maximum is way higher than 10 because I wanted it to show the vertex, okay? I left the scale as 1, I believe. All right, so the graph looks like this. So we're gonna find out what this value is right here. And like we mentioned, the intervals for the x values are 1, so it seems like this stops at 2. So again, we're just looking for the time, and the time is represented by the x-coordinate or the x-axis. So we say, okay, it seems like it takes 2 seconds for the dolphin to land back into the water. Okay, so let's confirm by looking at a table of values. Okay, all right, so right here, I've generated the table of values for you. Let's confirm. I should be able to see a 0 on the y column when the x value is 2. Do you guys see it right here? All right, so let's highlight it. So actually, one of the zeros are right here, 0, comma 0. That's the point of origin where the dolphin started. And then it went up, and then at some point it reached its peak, and then it had to jump back down or drop back down into the water. And we're trying to locate this time right here. So we can actually find it and confirm by saying, oh, okay, I see that. It's actually at 2, comma 0 because it took 2 seconds, which is super cool. So this is if you're using your graphing calculators. Now, some of you would rather and prefer to use Desmos, which is also a really great tool. Okay, so let me show you what it would look like on Desmos. You might need to do some zoom, you need to zoom out a little bit so you can really see it. So I cropped an image of the graph on Desmos. It's really easy to use. All you have to do is type in your equation on the left-hand side of the box or a text box, and it's a free tool. You don't need to sign in. But if you want, you can just create an account and sign in, so every other graph that you've created or you've used will be available for you, okay? All right, so we've generated this graph, and it appears, okay, it looks exactly like what we have. I cropped it, so we're just looking at quadrant 1, the positive x and y values, and I found that, okay, the time is actually just 2 seconds, and that confirms my answer, okay? So hopefully we were able to show you how to use graphing, okay, to solve for a quadratic function or a quadratic equation. So again, to solve an equation means to find the zeros. And what are zeros? Zeros are actually your x-intercepts. It's where the graph of the function crosses your x-axis. And that's what we did by graphing, using a graphing calculator or Desmos, or if you prefer to do this manually, creating a table, then you can do that by all means. All right, hopefully this was really, really quick and short for you. Please take your time to practice, and I'll see you really soon. Bye.